Public School. I'm your science teacher. We are learning chapter 8 motion. Yesterday we have started with equations of motion using graphical method. Today we are going to derive all the three equations. We have derived one equation in it. Let me show you other two also. Okay. So we will start with the same point from where we have stopped. Right. So here we are talking about that our graph, which is a velocity versus time graph. Okay. Now, as what I said, our object starts its motion from A and reaches to point B after some time t. So here, the initial velocity of an object, we call it as u, and we call the final velocity as v. So here, now we gonna plot the other points. Okay, so we call this point as O. Here, time t equal to 0, B, right? And I'm going to extend this. So this is going to be C, and this is D, and this is E. So at E the velocity is V, at D again the initial velocity is U, right? And here the time t is equal to t. Now then we started that let OA is equal to U, OA same as DC is equal to U, okay, OE that is same as BC is equal to V, and OC, AD and EB, right? That is your time t. Then the first equation we derived like that here BC is equal to BD plus DC. Okay, now BC is what? V, this is BD, and this is DC is U. So BD is equal to V minus U. Okay, BD is equal to, we call it as V minus U. Now we said acceleration is equal to change in velocity upon time taken. Okay, acceleration is change in velocity upon time taken. So which we call out BD, and time taken is OC. So this is A. So A is equal to V minus U upon T. If you take T on the other side, this is V minus U. If you take U on one side, you get V is equal to U plus AT. So this is the first equation of motion we have derived yesterday. Okay. So this is the first equation of motion we have derived yesterday. Clear? I hope you are getting what I'm trying to say. Now let's see the next equation. Okay. Before we see, let's see the next equation of motion. Okay, let me show you. So if you see the same way they have derived, V is equal to U plus AT. Now the second equation of motion, okay, that is quite easy. Now what we have to do is we have to take a distance. Now whenever we have to find out the distance from the graph, you have to find out the area. Whenever you have to find out the distance, you have to find out the area. Okay, so here we are going to find out the area of this one. Okay, so let me erase and help you again. Now what we are going to do again is So in second equation, what we will do is, in order to find out distance, we need to find out the area. So what is our area? This much area we have to find out. Okay, we have to find out this much area. So here distance is equal to area of O A B D C. Okay, fine. So area distance is equal to area of OABDC, right? So instead of DC, we will not, or you can keep it like this, okay? Or, so area. Now this, if you can see, this figure is divided into two parts. Can you see here? It is divided into two parts. One is a triangle and other is a rectangle, right? Fine. So we will use the same thing here. We will also do it in this way. We are going to divide this figure into two. Remember, we used to find out the area in that way. So we say area of triangle ABD plus area of rectangle ADCO or OADC. It doesn't matter. You with the name in either way around. Right? Guys, are you getting what I'm trying to say? Right? So it is OADC. And distance is represented by the letter S. Now, you know what is area? Area is what? 1/2 base into height. What is your base? Base is your AD. And height is your BD. Similarly, what is the area of rectangle? Length into breadth. So OA into AD. You can also write OC into DC. It doesn't matter. Again, I repeat. Area of triangle, how are we going to write? 1/2 base into height. So 1/2 AD into BD. And area of rectangle is what? Length into breadth. Now, see here. AD. What is your AD? Your AD is T. And what is your BD? Come on, what is your BD? What is your BD? We remember what is your BD? BD, I'll tell you, okay? So here, we have mentioned, remember acceleration is equal to BD upon T. So BD is equal to AT. So here we will write down AT plus OA. What is your OA? U. And what is your AD? T. So S is equal to half AT square plus UT. If we rearrange, we get S is equal to UT plus half AT square. And this is your second equation of motion. Again, what did I do? I have find out distance. So distance is what? Area of, you can also call it as a trapezium, which we have, right? OABDC. So in order to find out, we have to convert it into area of triangle ABD plus OADC. Area of triangle is what? 1/2 base into height and length into breadth. So AD is T. Now BD we don't have. So BD is what? We in the first equation only we learn BD upon T, right? You can go a little back in your video and then check. BD is A into T plus UT. Okay. Now let's see the third equation of motion. Now in the third equation of motion, what is your third equation? 2as is equal to v square minus u square. Okay, this is your equation. Let's see. Again, distance is what? Area. Area of trapezium. Trapezium. Now here you will see a trapezium. The earlier one what we wrote was a trapezium only. OABC. Can you see this? Is this a trapezium or not? Trapezium is a figure which has one side parallel and one side non-parallel. So this and this are parallel, and this are non-parallel. So we can call this as a trapezium. Okay, now remember, if you have remember the formula of area of a trapezium, area of trapezium is what? Half into height into sum of parallel sides. Sum of parallel sides. Okay, this is the area of trapezium. Now what is our height here? Our height is OC, right? And parallel sides is what I said, OA plus BC. Yes. Now what is your OC? OC is T. Okay, OC is what? T. What is your OA? U. What is your BC? V. We didn't get still our equation. Now you must be saying, sir, now what? It's quite easy. See, we learn what is A is equal to V minus U upon T. Remember what we learn? We learn from the first equation what? A is equal to V minus U upon T. Remember? So can I say T is equal to V minus U upon A? T is equal to V minus U upon A, correct? We will use this here. So what do you get? 1/2. Instead of T, what are you going to write? V minus U upon A. And what is our original? V plus U. Now this is S. So denominator is, this is V square minus U square upon 2AS. Right? If I'll just erase this and I'll write down here. So we get S is equal to, V square minus U square upon 2AS. Sorry, not 2AS, 2A, right? Because in the denominator it is 2A. When you take this A on the opposite side, is get 2AS is equal to V square minus U square. Can you see? This is your third equation of motion. I'm sure you have understood properly. This is a very long question. This might be asked in the exam and you have to write all this long method, right? So this is how you can derive 3 equations of motion. Guys, let me show it in the textbook. It is also the same. Can you see here the second equation of motion? OABC, it is a trapezium, so it is rectangle plus area of triangle. So length into breadth, 1/2 base into height. So UT and AT, right? Remember I told you BD is equal to AT. So S is equal to UT plus half AT square. Now third equation again as what we derived, S is equal to what? Area of trapezium. That is 1/2 into height into sum of parallel sides. So U plus V into T upon 2. And then we say T is what? V minus U upon A. From where you get? From the previous equation. When you put in, you get 2AS is equal to V square minus U square. It is a very long question. I want you to see this video 2-3 times. Then only you are going to get. And try to write and derive this on your own in your book for the practice. Okay. Now there is one more last topic left with it, which we are going to cover next. And I'm going to show you the word problems for the same. Okay. Bye. Till then, take care. I'll see you in the next session.